Welcome to this course on optimizing Python code with pandas. My name is Leonidas, and together we will explore the most efficient ways to perform a variety of tasks using the pandas library. Even the easiest task in Python will have a faster alternative, which will be very handy in situations where time matters. For the context of this course, we will use a function which captures the current time of the computer in seconds since the 1st of January 1970 as a floating point number. This function is the time function from the time Python package. Each time we're interested in measuring some code's execution time, we will assign the current time before execution using the time function, execute the operation we're interested in, and measure the time again right after the code's execution. In the end, we print the result in seconds in a compact but meaningful message. Before we apply the notion of time efficiency in any pandas-related problem, we will compare the difference in efficiency between a list comprehension and a for loop in a toy example. We're interested in calculating the square of each number from 0 up to 1,000,000. At first, we will use a list comprehension to execute this operation, and then repeat the same procedure using a for loop. As you can see, we store the time each operation began, then execute it, and in the end, store the time it ends on a different variable. The executed time is just the difference between those two variables. Make a guess. Which method is faster? I'm sure you guessed it right. In the majority of occasions, a list comprehension is a faster way to perform a simple operation compared to a for loop. Keep my words in the majority in mind though. One last interesting finding could be to see how much faster a list comprehension is. We can see that it is 87% faster than a for loop. Impressive, huh? While the previous example might not appear like a big improvement, we will work on a second example to illustrate the importance of efficient coding. We're interested in calculating the sum of all consecutive positive numbers from 1 to 1,000,000. The most intuitive way to do it is by brute force, adding each number to the sum one by one. A more clever way to proceed is to use a well-known formula. When we want to calculate the sum of all the integer number from 1 up to a number, let's say capital N, we can multiply capital N by capital N plus 1 and then divide by 2. And this will give us the result we want. This problem was actually given to some students back in Germany in the 19th century, and a bright student called Carl Friedrich Gauss devised this formula to solve the problem in seconds. After running both methods, we achieved a massive improvement with a magnitude of over 160,000%, which clearly demonstrates why we need efficient and optimized code even for simple tasks. After this brief introduction, I hope you're as excited as I am to measure the time needed to run all these sophisticated functions. You'll be surprised by the results.